Hello, everyone, and welcome to the broadcast. We're going to be continuing our game dev project today, just making sure all of the dials are turned properly here. I think that's working. Yeah. Oh, quiet, I think, but should be okay. Hey there, Jay. Welcome, and Tass as well. Welcome, everybody. Let's check in with kitties real quick. Sammy is on the table. Molly and Sherbet are near the TV. Mason passing through. Ember getting a snack. You can just see Sherbet in the lower left of the play area there. I rotate the YouTube critters on a perpetual camera stream. There are some channels that essentially stream a very long looping video and periodically change it to be a different one. Every now and then I will hear like frantic thumping against the little acrylic shield over top of the TV. Anyway. So, we are going to be trying to finish up the collision logic today. See if we can catch this before she moves. Not that one. That one. Just mention no names because it will make them move. You can see. Sky is on my lap, so they are not able to approach to compete for shoulder space. Sky is being all snuggly. Alrighty. So the thing we need to wrangle here is the output buffer and how we lay it out. Hey there, Key. So the general pattern with this, I call you output bytes. So this is kind of where we hung up last time, was laying this out. So what we've got is, the first part is number of collisions, and then all of these are so we have how many collisions there were, and then the indices of the thing it collided with. Each time we iterate over the collection, we're going to be doing bidirectional collision checks. So when we check index 1, it's going to check itself against everything, and it will check that bidirectionally. So it will be, does 1 run into 2? Okay, does 2 run into 1? That sort of pattern, and put them where they are supposed to be. So this is not really the right notation to use. We'll put them parenthetically. Not curly braces either. So in this case, like, oh, there is one collision and this is the one it collided with. We will iterate over the collection, look for ones that have more than 0 here, and then go that far through their collection. We will have to have logic that stops at 20. And that will be a magical number. It has to be a magical number because, well, okay, we can pass it in. I don't know that I want to, but we can pass it in. For now, we're not gonna. We could have it as a uniform within the code and just say, this is what it is when we create the shader. Let's get it working first. So this is okay. So the first float is actually it'll be uints. The first one is how many collisions there are. Then there are 20 more slots after it. Max collisions here. So each one is currently 21. So that will be max entities times size of the uint times 1 plus max collisions. Then when we're iterating over it in the shader, to find it, we need to have, where is it at? We ran into this last time. When you're dealing with C-style code, the declarations must happen before. With some other later languages within a class, you don't need to worry about that. But it is the reason that using and includes happen at the top. Because at that point it can say, okay, this is where you can find everything. Again, a lot of modern languages can short circuit that. They can say, okay, look for the using files. I don't care where they are. Put them at the top. But when you're dealing with something like C#, the includes have to go at the top, and I'm sorry, C++. And sometimes you want to put directives around the code that says, once this has been included, do not include it again, because there's something fiddly about the way you're defining stuff. Sorcery and such. You know, you don't want to draw the demon summoning symbol twice. Okay, so we have which one we're iterating across as far as which block. So this gets us our raw index, and this is the max number of entities that exist. Call you an output. Collisions. Buffer. This is going to cause some problems here. Collisions. Collisions. Clearly, collisions would be better. Ugh. This guy jumping off of me. Disrupting the ecosystem here. Okay, let's... Okay, so this gets us our index, like which entity we're looking at. We're checking if it's collidable. Then we're going to run from the next index all the way down. Assuming the target is collidable, the current one. And then if the second one is collidable, and there is a collision in either direction, then we would add this, but we need to set this up a little bit differently. So we are going to do 2 checks in this. We're going to keep this end here for a moment. Hello, Ember. Hello. Well, come on. Ember has come over for shoulder snuggles, and I must give her shoulder snuggles. Hey there, Rogue Radio. Hack cough. We are just getting started. We're looking at our shader code here. Does it still compile? It does not. Okay. Line 79. There we go. Huh. So for my notifications, I put additional ones on Blue Sky and Twitter, as well as in the streams channel on the Discord. And I at everyone when I do the Discord one. Those are other ways to get the notifications. I do know that YouTube notifications in similar can be a bit unreliable. On the YouTube side, you might have to go in and, click and unclick the bell and do a little dance or something like that. I know people say that sometimes they lose notifications to channels that they follow. Why that happens? Good question. Okay, we're going to move this logic into collision check. So we're going to say if source in target, if it can collide, we're going to go through and actually set the data. It can get real esoteric what they're up to on the platform at any given time. Okay, so if the source mask hits target category, then we're going to do our switch for collision type. We're going to do if... I'm typing around a cat on my right shoulder at the moment, so my typing posture isn't great already. Cat, which must be reassured every time I move my arms, inhibits it further. If collided, then we are going to do this. That's not quite right. So this is the source index. We also need the target index. Ugh. But that's where we're going to store it off. We already know that we have to jump through those hoops to store it off. Okay. Okay, move. Ma'am. See, when I shift my shoulders to type, that throws off how she is like bracing herself on my shoulder. So to correct that that imbalance, she stands up and blocks my face and the camera. So she must get more attention. She'll buy me some time. It's equal to source times. Again, we are going to need to set up a trick for that. Like again, we'll set this as a uniform in the shader when we initially create it. That 20, the max of them, is a known commodity. Okay, so collision data. We want source index. It's where we're going to put the information. Okay, so this gets tricky. We're doing atomic add because we need to know how many collisions there already are, and we're going to claim one of those numbers. So that's where collision index comes from. Is we're going to get whatever number is here, and we're going to add 1 to it, and we're going to keep the original number. So if it had 0, we're going to add 1 to it, and we're going to get 0 over here. And this will be +1. This is relevant. Is then we're going to do collision index here. So that's which one we're going to get, and that's source index plus collision index is equal to target. So when we call this, we're going to see if they can collide. So if the mask and the category overlap. Right up here. Bitwise end of mask and category. If it's not 0, that means there is a collision. No, that's not quite right. No, that should be correct. It's as long as some part of the mask collides with some part of the category. Yeah, kind of fiddly, but that should be fine. So we do collide, or we can collide. If we do that, we're going to switch on the shape. Right now, they're all circles. So we're going to do a circle check. This is permutations. And it gets complex very quickly. For practical purposes, there are going to be at most 3 shapes. Oh my god. One moment. Notifications. This goes here, this goes here. So they're all circles currently, but at most there's going to be circles, capsules, and rectangles. Capsules are essentially a rectangle with circles at the end. Usually like top and bottom of the rectangle. Creating kind of a pill shape, you know? That's why capsule. And then rectangles, are rectangles. The difference with capsules and rectangles, though, is that there is the idea of rotation to them. Oh, yes, we're making a game. We're making a sort of a Survivor style game. Its content is very much based on character lore. There's going to be a bit of if you know, you know in there, at least initially. In that there will be references to the old Noida playthroughs. If you know what a boop is, you know that that's a big deal. To get our source index, we're going to add the collision index. But right here, if we're going to call you collision count. Number, collision number. So the first collision number we'll get, it'll start at 0. The first one we'll get is 1. So 1 through 20 inclusive are valid collisions. Everything after that we skip. Sadly, we are wasting calculations here. Like we're doing the collision check up front without knowing what this is. We should be able... No, we can't mess with this number is the problem. We could probably do song and dance on that. But for the time being, the can they collide check should be enough. We will be able to add more for optimization, though. For example, we could do things like, what is the distance between them? If it's greater than this, it will never collide. But that's not a certainty if you're dealing with, like, beams or similar. So, again, for now, we're actually going to brute force this. Okay, so that will give us those. Should be correct. Let's check and make sure it still compiles. It does not. Let's see, 86. Okay. collision check index I to index. Okay. Let me go back here. We want to look at a couple of steps. We want to look at where we are computing the collisions. We are not updating this buffer. Output test uniform is a, I mean, output uniform is entirely output. So we're never going to update that buffer. We'll keep that removed for now. Then when we get our collision, which is an on game start, if we are computing, we're going to sync and we're going to get our output buffer information. So when we start this, it should be full of zeros. There will be 3 entities at the start. Oh, we need to change that actually. Okay, so we're going through max entities. Not that, it is times 21. Int, we'll just call it an int. Collisions +1, so that gives us where the collision where there is a collision, and then so 0 through that, and j is less than x collisions. One is less than or equal to one based index here because we're adding j. Count index is equal to I times max collisions +1. So we're finding where the number of collisions are. Count index. if count index plus j. Okay. So we're iterating over the whole collection. Again, we're brute forcing this. This is as messy as it can be. Some of this is by necessity. But since it is unlikely to have a lot of collisions, and we are hopping along through it, we're doing 20,000 iterations, which isn't free, but on even a modern potato system, that's negligible. Now we're doing it 30 to 60 times a second, which does change the equation, but, you know, we'll see. All right, so we're hopping along for every entity. We find out where its index is, which is max collisions plus 1. And that is because the index, the first cell in that index, the first entry, is how many collisions there were. The subsequent 20 or max collisions entries are what it collided with. So we get that index. If there are collisions entered, if it's greater than 0, then we are going to iterate over the collisions in it. So we're starting at 1 so that we can do that index plus 1 here, plus j here. We're going to go until we've hit all of the collisions or we've hit max collisions in case there is a problem. We don't want to buffer overflow here. We don't want to overrun our indices if we have messed something up. So we're going to break on this. And we're going to walk up here. We did not get any collision information there or there. Okay, so it is not working. Let's double check that we have. Shader is functional. Well, shader runs. Okay, so we need to know what our results are, and we need to know what's coming into the buffers. Actually, let's run this on the Godot side and see if there are any errors that are showing up on the Godot side. There are so many errors showing up. Uh... 153, 121 into 153. Here. Apply to binding. By one ID. Which means this isn't forming correctly. We have an RID for it. RID of 0. This did not work. We don't want to buffer update. Oh. Okay, we should get a result this time. Yeah. So effectively, the shader was never actually running properly. No collision there. Collision there. Okay. It lists 17 collisions, but indicates none. Third entity is 42. One with 42. One with 17. But it did not... Oh, okay, there's no collisions listed here, though. 21 should be entity 1. This is saying there are 17 collisions. Look at that shader code again. For every subsequent one, we iterate over it. If they're collidable, we do a collision check to index to I and I to index. Because these are the entity indices here. Data size is how many entities we have, which is always 20,000 here. So 0 through that will be index. So this is 4 and 4 and 64 and 20. There's a bit of overflow, but that's okay. Well, thank you for the Twitch subscription over there, Key Bennett. I appreciate it. Beverage. What are you zooming around about, huh? Has unlocked the remaining emotes. For reference there, Key, so the old emote, the science emote, is using an image of the catbots, effectively a channel mascot. That is its image from the Noida mod. That is where they come from. For science generally meant this is either going to be cool or it's going to end this run right now. Do a collision check. Source index is whichever one times 21, because again, it's 0 and then 1 through 20. Yeah. Collision number, we get whatever was in that index. Add 1. Source index, increment it by 1. It's no more than 20. We set that to the target index. Collision number should be getting updated. We should never get anything that doesn't line up with that. So the idea that that number was 17, but there were no entries there is strange. Okay, let's... run it on the Godot side again. Not accumulating any errors. That's good. Go back over here. So we know that this is going to be true. That as it's iterating, that will be a number. At least it is supposed to be. Okay. So this is the 4th entry. So count index 84. And we're going to be looking at 85. So if we look at our results, at 84 has 1 and then 42. Now I want to jump up to here again. Okay, it's not clearing it out. Okay, we're getting that same buffer again and again. Okay, well now we know that's happening. We also need a way to say it has collided, it can't collide again as quickly. But that's kind of an iframes thing. Okay, so the buffer isn't updating. So here, all right, we are getting output buffer each time, so that is staying true. What I wanted is that it empties each time. And there isn't a good way to do that. Because we, in the shader. So what I would like is that the result never comes back up. Let me check something real quick. Right only. Just looking at this code and make sure I've got it written correctly. There's a way to do it in a compute shader, but All right, we're going to take a quick break. I will be right back. And I'm back. All right, we are going to try to just brute force this once again. So we get here the first time and our output bytes is a whole lot of zeros. Then we run it again, and the next time we get here, still a whole lot of zeros. Again, not the most efficient way to go about this, but it is a way to go about this. So then we're going to look for our games, our on game start step. And we're looking for these. Still operating at 120. Okay. Back to our locals. We're going to look at result. Actually, no, first we're going to look at this. So the fourth entry, well, it's the fifth entry, has so we're looking at 84, has one collision. It says it collides with 42, which is the third object, which should be the entity spawner, the little blob that sits in the lower right corner to start with, because the first is the player, the second ends up being the door, and the third is the things that live in the room. Okay. Now we're going to let this run again. Again and again and again. Okay, we let that continue for a while. Then we are going to break here again. So 84 changed. Our index is 2,247. Okay, one collision, and with 1932, which will be with one of the blobs. Okay, so this is saying there is a collision. So then we're going to say entity source, entity target. So this should be equal to entity manager is equal to resolve entity manager entity, and this is I equal to that, and that one is this one. As an int. Not greater than 0 there. Okay, and then we're going to do... What did the old one do, just to be sure I'm following pattern properly? Callback message. These are messages down here to physics. Add the collisions. Okay, so it's effectively this. Data collision manager. If it's still active in collidable as of this moment, actually no, it would not have gotten a collision if it wasn't collidable, but we're still going to check and see if it's active. So collision message source to target. I don't know which in particular it is, but this particular music track always reminds me of the American McGee's Alice games. I think it's just the type of music. Oh, my apologies. Hey there, Lunar. Okay, we are getting errors of some kind. Let's check here first. Hey, Thrax. My sleep schedule has been a problem lately as well. Okay, we are not getting source and target entities. Alrighty. HD3 and... Entity 42. So get entity isn't working. It needs to be base entity manager. It's not the first time that I have done that, and it will not be the last time. If I'm going to end up implementing any sort of redeems, it will be something custom and not something Twitch specific. Okay, those are never even being called. But how? Oh. But we're expressly calling get entity. Right here. Why you no work? Mayhaps I am thinking I'm calling a function that isn't the function that I think I'm calling. I am. I am. Virtual entity manager. Uint ID. Home style mini game where you start out in the enemy basement, so they extend your death traps all over the castle. There was a series of Home Alone games in the NES Game Boy era, based on the Home Alone franchise, and it was super bad. Protected? Yeah, well, okay. Very different game. I believe Night Trap is one of the really infamous games that ended up being at the forefront of the original video games are super violent and corrupt in the youth. Let me see if it is. Oh yeah, it is. Yeah, that wasn't really. That was a different genre, let's say. Build, build, build. Well, no, the original Home Alone NES game was much more. It was side on view, but the interaction was an esoteric placing of squares with letters on them in very vague symbols that if one of the enemies touched them, they would like fall over briefly. Ugh. Nope, 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 nope. No, when I mean Night Trap was a different genre, I mean it had nothing to do with actual traps. It was largely just scenes of guys jumping out and attacking co-eds in their bedrooms. Like, press a button for assault. That was one of the games where legitimately it was kind of questionable. Okay. But no, I agree. The Home Alone games were in the same spirit of pretty much all other IPs of that nature. Or IP based early video games. Okay. All right, well, we're further along. Where it airing out this time? Because this seems to have a problem. Right there. This didn't go away. We're not getting an error state. Circle, and it is of a type blob. Doesn't seem right. Okay, no. Wind up mouse is source. Target is got the blob visual. That is correct. Handle message. was acted on and consumed. So we go into our entity manager. There's an on. We want the world start step in here. Yep. That one. So the blob because of the impact. And then it should be the mouse because of the self-damage. Yep. Move entity internal. Remove it by category and put the ID back. We're going to invoke remove. So we set it active as false. I mean, you meant it. You did not mean it in that context, Lunar. I don't think that changes the accuracy of the commentary, even though it was unintentional. There is the state of the world in at least the US is such that there are a non-trivial number of children that grow up with the active threat of death on their doorstep, you know? Okay, we're going to dive into that. And we're in a visual with the remove entity message. This one should be the blob, yes. Wait, what? Oh, okay. No, this is the target entity of the blob is that it is aiming at the player, because it is moved towards player. So that's the visual. And now we are in the shadow. We move through the shadow. Oops. Okay, so that blob should be gone. But is still there. And we're also not getting any subsequent collisions. I have the stream for tomorrow prepped already, and I feel like its title becomes increasingly accurate as we move along today. So we should, based on what we're seeing, we should get this a grand total of once. Yeah, that one collision happens and all subsequent ones cease. Okay. We're identifying where in the loop things are breaking down. Source and target. So the first one, a collision happens, but the subsequent entity does not go away. Okay, target this time was null. $42 again. Four into 42. So that would be 84. So we are getting collisions, but the target isn't right. So that's 735. Same thing again. We are getting it stacked because they're colliding for multiple frames in a row right now because we're going to get a null here. Autos. There's one entity in this category, which is the player. This one. So once again, one in here, which is a door. And then these are going to be almost certainly blobs. Yeah. Okay, so these are enemies. No 735 in there. No 735 in there. Huh. Okay, so we are explicitly getting the wrong index. That is our current problem. The wrong entity is being indicated here. Topics can be all over the place sometimes, Thrax. Okay, when we are recording it in collision, It's not target index. That's why. It's target. This is the actual number in the collision data. That's the actual entity. This time you will work. Still not working. Okay. Yep, data storage both at runtime and also as like save data, data that you will load up is a big consideration. A lot of game engines give you like a basic form of that. Like Godot has a data structure for things like saving data. Source in target exist. Target once again does not exist. 42. The I is 3. Yeah. So we're looking at 63 and 63 says entity 1 be the door or the blob. This implies that our data structure for where the entities are is not properly updating. But the first one still should have removed it. But its visual and its its visual is sticking around, and all subsequent collision checks aren't updating properly. At the very least, active is not updating properly. All manual code night shift. For the most part, my general opinion on vibe coding is that it is entirely corporate hype. There are just too many problems that people... I would be of a different opinion if we were seeing results that actually were good. But we're not. It lines up with everything else LLMs are doing for the public sector, for public individuals. Well, I don't have an encrypted structure, Thrax, but all of the data for the game, aside from textures, exists as JSON, whether it is interpreted from CSVs or in raw JSON format. and even the textures are read into kind of a data management thing in the game, because one of the elements that we want to have is the ability to do like drop-in override modding. Okay. How is this sticking around is the question. Because we know a collision happens. We know that it gets killed. Okay, we invoke removal. Collision Manager says detach the collider events, which will stop it from colliding going forward. Collider, it has an entity. We no longer care that it was changed or removed. Then we're going to remove the collider data. So this is for entity 42. So if we look at data in our collision manager, but yeah, Knights, I think even with a lot of the art resources that are being generated by this stuff, they're only working because people are saying it's good enough, paired with hype that says it's as good as. But it generally isn't. It's, if you don't look closely, it's the same way with like stories written by or any sort of interaction with. There is no understanding, there is no thinking. It's ultimately just mush it into a shape, and this shape aligns with the key codes that we have requested. So just as often as you get like bad commits and damaged data structures and the like, you get things like, that's not at all what I asked for. And the biggest threat on this is garbage in, garbage out. Let's see, which track is this? This one is called Hear Me Out. Okay, so we are extracting the byte data. So data 42. Currently is collidable. One of the fun AI stories I saw recently was a company that was touting that they had created a conversational pattern to it. I don't know which company was claiming this, but that they made it better at conversation. And the question that they posed to the chatbot was, what is your favorite film? And it said that I have to look back to the 90s, and I think it was The Godfather. And the reply from the person was, you mean The Godfather 3, because Godfather was 70s. And that chatbot went into a death spiral. A great deal of, because there is no escaping that as far as that kind of conversation from the source information that has scraped on the internet. That's not even remotely true. There isn't an escape vector for it. Was there ever a seahorse emoji thing all over again? Is that there is no proper escape in any conversation that it has parsed. And since there is no understanding, no meaning to what it is emitting, it can't end the conversation because there is no example of that anywhere in its corpus. Okay, so data 42 now has been purged. I should have looked at... That is our collider data bytes. Uh, 42 would be way down here. Okay, that's potentially part of our problem, is how to get this wrangled, because this is supposed to be interpret, like, this span is not its own data structure. It is this array, this byte array, interpreted as if it were a span of this structure. But that might not be true. We would need to find the right offset. Let's get that again. This is critical. If this doesn't parse correctly, then we have a problem. Looking at... yes, Godot and C#. Right now, we are debugging a compute shader that does collision for us. And I am trying to wrangle the input and output data without having to do as much copying as is minimizing the amount of copying I am doing by interacting with the data in single passes. So this, like, memory marshal song and dance that I'm doing is to avoid actively creating, like, new arrays or doing bulk copies over the memory. Can we get away with that if we have to? Yeah, but I don't wanna. Okay, we are going to do that, and then we are going to look at our collider bytes. So I need to know if any of these changed. I'm not seeing any indication of that, but these bytes, the size of it is much, much bigger. So it is possible, but since we only have a few of them... Hey, Stiggy, what's that Docker container do? Okay, this isn't doing what it is supposed to do. This operation is supposed to make these memory areas identical. Or at least, it doesn't seem to be doing what it's supposed to do. Because we're still getting entity 42 showing up, and that will lead to problems. Okay, and this time I will totally remember to get this back again. Creates a span, and then it's supposed to be reflected. That is one of my cats, Night Shift. That one is Mason. As good a reason as any. Let's see where they are. So Ember is across from the keyboard. She is, as far as your point of view, top center. Sky is over by the food dish getting a snack. Let's see. Sammy would be up and right from the lower left camera. Unclear of where Sherbet is. Oh, no, there he is. Sherbet is forward and right of me, to the left of the right center camera. Unclear where Molly is. There are 6 cats. Usually, at least one is visible. Okay, this is supposed to be the same thing. So when I do this, the span that results here, those are mine. Hello, Sky. Yeah. Yeah. There's still plenty of food over there, so that's not the problem. He just wants attention. I believe GLSL is, I think it's OpenGL shader language. And then there's Godot SL, which is technically what I'm using right now. It's the one that Godot can interpret. There are differences such as... that's what I mean, Thrax, is OpenGL shader language. So the OpenGL is kind of a low-level generic graphics programming layer. And then shader language. So the GL from OpenGL and then the SL for shader language. The Godot variant can do things like this. I may be mistaken on the first part, but the SL is definitely shader language. But this compute is not how GLSL does it. This is a Godot-specific way of doing it. So why work that way? Okay, let's do this as a test. But we're not going to use vars because we're not a savage. Just going to pop this in an arbitrary spot. Do it on our ready. Like It's right here. You're declaring it as a float array, but you're using it as a variable. What's wrong with you? And this is a span of floats. Oh, no, okay. This is a span of byte here. But that's not the order that we want to do it in. We want to do it like this one. Well, I see you in my feed. Would I have any advice as far as, like, do you mean as far as C#? Or something else? Coding in general, one moment. As far as coding in general, find tutorials and run through them. The prevalence of Hello World as a programming exercise is perfectly viable, or at least it makes a lot of sense. But past that, having a target, like what do you want to make? Starting smaller is a good idea, but I call it just do it. Like, start working on it and learn as you go. You won't understand a lot of the stuff up front, but you will pick it up as you go because you can learn from a lot of resources that are out there. Based on, I believe, I think Thrax is using that. So Game Maker, Godot, those are good languages to play with, or game engines to play with. Godot has its own effectively programming language, a GD script. So you could go through that pattern. You can use resources for those game engines to kick off into other programming languages. Like if you're trying to learn Unreal Engine, you're going to learn C. If you're trying to use Godot, you're going to learn GD script or C#. Technically, you can learn C in Godot, but oof. I don't know if Game Maker has interfaces for outside programming languages. But I find you learn faster outside of an academic scenario. I find you can learn faster just by running with it and learning as you go. This project that I'm doing is the first time I've touched Godot. It is the first time that I've done a major project in C#. I know how to code in C# because it is a descendant of C, and I was already familiar with that. And those coding practices bounced cleanly into C#. Familiar with C in a general structural sense, not in a I'm good at it sense. We're going to call this, there are 3 of them. And then we're going to say input 1 is equal to 2. Okay, so in these locals, we have input bytes and we have input. So input bytes is a float array, is a byte array. There are 12 bytes because I have 3 floats, which are 4 bytes in size. Then input is a span of floats. It's size single, but it's as floats. So I can see these. That shouldn't have anything. Oh, yeah. Okay, so input bytes is changed and input is changed. Okay. That do what it's supposed to do, is we're casting byte to float to get to here. Okay. So then down in the shader collision manager, when we get back on collider remove, we're going to remove the data here. And we're saying this span of shader collider data which we're going to pass in the collider data bytes. So we're casting the bytes as shader collider data. And we are going to alter that one. Then what is the first element of shader collider data? It is a uint of a shape, which should be pretty clean since it's a 1. They're all a shape of 1. So if I go into our shader collider manager, and when I'm here, we'll get to here. Let's stop that. We are going to, we know that 1 or that 0 is a thing. It will always be a thing. Zero dot shape is equal to 4. So as soon as there is a collision, we're going to get a removal effect. Okay, so we're looking at this collider data bytes. So we have a 1 in this first set. Now it's a 4. Okay, so collider data bytes has updated. This collider, this entity, let's look at E as a local here. Oh, this collider. entity has an identifier of what? Or start it again. ID of 42. Because those bullets should collide with these. But we're not getting any sort of collision after that. As noted several times before and onward, hello Octojinx, welcome, and thank you for the Twitch follow. So collider refers to a data structure that is largely just something that reacts to the events of an entity. And an entity represents like those blobs or bullets. So whenever that entity moves, it tells the collider, and that collider tells the collision manager to change the corresponding data. The collision manager could handle this directly with the entities, but the shader collider is there to carry this data here. Entity data. It's got to be happening. Invoke changed. Okay. So position updated. So this is on collider changed. Go, we update the collider data. We cast it and we set the data. So every time an entity moves, we get this effect. Or we cast from byte to shader collider data. And then we update the data. Sorry, we cast that data as if it were a span. Let's at least get... run it on the Godot side and see if we're getting any sort of errors popping up. It's working. It's working. So for reference, the reason that it's slowing down right now is that each second we are creating 3 to the 8th of those little mice. Physics tick-wise, we're getting very few of them. Visual tick-wise, we're sitting at about 8. There are about 19, currently, a little under 20,000 of those little gray mice. This is a state you will never get to in the game. It will be less than this that you would be able to get to. But for reference, it takes about 1 second to go through the whole animation, the whole bounce and stretch of the little guy. So it should be about 1 second between arms straight out, down a little bit. To give you an idea of how much it's slowing down. But this is the reason that we're doing collision on the GPU. Because while we don't want this many, we want to be able to have a whole bunch of them. So after about 10 actual seconds, as far as the simulation is concerned, these entities, these little mice will start to go away. You can see them starting to go away because there are more of them spawning in the center here. Only 3 to the 5th, though, which is, a lot less. But we will start seeing our frames recover soon. For some values of soon. All right, up to 16 visual. And back up to 120 with about 2,000. At about 2,000, we've lost a few frames. Yeah, let's say we lose about 5 to 10 frames at about 2,500, 2,400 mice active at once. It varies based on when garbage collection actually decides to happen. Our object caching isn't as robust. So all of the collision logic, like the actual collision calculations, are currently happening on the GPU. The result of the collision is on the CPU side. How they move, like the logic of how they move, is CPU side because of this. This is a sequential behavior pattern. 3 per second, and after 3 seconds, they will split into 3 to the 4th and start to try to orbit the player. So it'll go 1, 2, 3, and now. So all of this is CPU side footwork. We could shift this around to make it a little more visible. But the order that those happen in, how they happen, all of that is controlled by one of the core game systems. And we can make it weirder if we want. So now they're moving in an S-curve as they go along, and then when they burst into that extra set and start spiraling, they're still moving in an S-curve around the player. But because of that curvature, it brings them closer to the player, which allows them to keep their kind of gravitation around the edge, because the circular motion is very strong. And if we start moving, because it's a counterclockwise motion, you can see they start to kind of create a lower arc around the player. But all of these different movement patterns contribute to that. No errors? All right. This is actually working. Right now, we're only doing collision as circles because I don't want to do all the extra math for other shapes right now. Because it's an exponential increase every time I add a new shape. And anything past circles gets a great deal of increasing complexity. Well, okay. Its raw shapes are still not terrible. So a horizontal capsule, a rectangle, and a circle are all things that would be pretty straightforward. But the trick is, if I add horizontal capsule, then that has to be able to collide with horizontal capsules in circles, and circles have to collide with other circles as well. So by adding the other one, I now have 3 different collisions that I need to worry about. Not counting like the duplicate pairing doesn't count. So we have we have at least some uniqueness breakdown there. But yeah, it starts to get increasingly complicated, and the logic for creating the collision is trickier. Circles are viable mostly, but as far as the world logic is concerned, the feet, or whatever part of the object is, in practical terms, touching the ground, since this is 2D, it's going to be like around the feet of the object or directly around a projectile. That's the part that collides. Fiddliness and all of that, but this gives us our actual colliders. Nice, nice, nice. So we are going to do a quick break. I will be right back, and then we're going to start talking about the next thing that we're going to do. And the next thing is... well, the next thing we're going to talk through again because it's another layer of fiddly. So be right back. And we're back. Okay. So the next thing is world movement. There are a couple of things that I want to accomplish with this. One of which we can probably kind of hack together. So let's make that. For the time being, we're going to put it in let's move the player. Because effectively, we're starting with this as the first layer of movement, and we're going to change the way that we have a move to the target. Because this is a special one. All right, let me moment here. Gonna avoid blinding everybody. Okay. So effectively what we're gonna have here is I have a big box. I have a center of that box. Pretend that's the center. Just so. Microsoft, how did you break Paint? Like it is legitimately one of the simplest programs they had, and they have progressively made it worse. But I have this object. So I have a square, I have a center to it, and then I have all these different vectors leading to the center. And each one of those vectors represents a pixel on a texture. I mean, technically, a two-dimensional array of vector 2s. And whenever we want to get to the center, we align this center, we align that with the position of the thing that we are tracking. And we compare that with the offset position of the entity we are trying to move and say, okay, whatever point you are standing on, whatever the exact point is, or rounded to the nearest integer, that is the direction you need to move. So that no matter what, it's not consulting, like, where is that entity, draw a point to it. It's, you will move this way, period. And I can align that anywhere. Is this substantially different? Not really. But it's the first stage in the process. And since I'm going to be consulting these anyway, we should be all right. So this is going to be a proof of concept pass, where what we're going to do is we're going to create a marker to move in a particular direction. We are going to have it stop if it doesn't have a target. So it will not consult the line if it loses its target. We'll be able to add more to that, but we're going to call it move on grid. Public class, all in the same namespace. Extends I behavior. Don't I have an I behavior now? No, okay, I haven't made it an interface. Doesn't really need an interface. JSON constructor. Equal to we're going to say a vector2 array. No, it's static vector2 array. Then we'll configure it in here. We won't be doing it this way. This is not how it will be done. We will have a object that we load in to represent this. So we won't have to build it. We will just load it in and consult it. The plan is to use a bitmap for this, a texture for this, because the the full color vector, the colors being vector 4s essentially, will give us the direction and potentially any other information we need. Oh. I think we have to do that. There's a way to do this, and I'm blanking on it. We'll just look it up. Okay, well, that should be straightforward. Grid is equal to 10. Yeah. Oh. There's no constructor. Okay, so we create the grid. Actually, odd number. This is 0 through 10,000. Be 5,001 should be, yeah, 5,001. So it would be index 5,000 is the center. I is less than. Yeah, we're being very hacky here right now. But we're going to. This will be a fixed thing by the time we actually implement it. Okay, so that is, yes, so it should be rid I j is equal to center minus new vector 2 I j. Okay, so the distance from this to center, and we can do we'll normalize it. So this is just the direction to center. Then for actual movement, it's been a while since we've created a movement. Extends a movement behavior, actually. So it'll have a targeter. Need a duplicate. We need a duplicate because it is a catalogable. Just in case. So this should put us well within range. It's a gigantic vector 2 structure, but okay, and then we'll add a process message. That will be the same. That will be the same. But here, so we have our delta. Movement, entity movement is equal to new entity movement. All right, so entity movement. Velocity. So, float of delta times let's clear this. Clear this for the moment. So we need the offset being the target's position. So this is if targeter dot entity. There needs to be an entity in the targeter for this to do anything. Then, so we need the target's position. That is the offset. That becomes 500, 500. $5,000, $5,000. So let's see here. To offset is equal to the target is equal to targeter if it exists dot entity. Target does not equal null. is target dot position. Okay, so this is the offset from the target to 5,000. Doesn't really matter how we apply this, as long as we apply it consistently. Our grid position is equal to t dot position plus offset. So this is from the entity to the target. And if we add that offset to the other one, that gives our grid position. So now that is grid is grid position dot x and grid position dot y. Integer we'll force it to round we would do this a little differently to make sure it is handled consistently. And we add that. Okay, so if we have move on grid, then they are going to move towards their target. Since this is a catalogable, we should be able to get this properly. We are going to get that. Explorer. Data, we're going to look at our enemy and verify what we've got in there. Are we we're not hard describing it. Okay, so it's not here that we're defining it. We're going to be defining it in the level JSON. Okay, yeah, that should be good enough for now. Okay. So we spawn that, then we're saying we're using behavior movement to player. Okay. So we're opening up our movement file. Movement to player has move straight line with a targeter of target player. And we want to change that to a move on grid. And then we're going to run it, and it's going to work first time. Oops. Yeah. If not grid done. We wait and go. Okay, so we won't need to do that gigantic iteration. Hey there, JJ. Welcome. Okay, so we won't be doing this in reality. We are going to make this... we're going to store this off. So instead of a grid of vector 2s, we are going to make a new texture, and we're going to save it off. So we're making a texture 2D. Just put that up there. But actually... There's a trick to this. I thought I was doing this elsewhere. All right, real quickly, we'll look that up. Image, we say create from image. Okay, this'll do. Use bitmaps, so we're just going to say false and image.format.rgb8. Empty, and we are going to say it is 10,000, 10,000, false, image.format, RGB8. No, we want it to be RGB alpha. Then we are going to, we make it an image, we fix it. Yeah. Just create that. Not blocking it that way. Huh? It's not a thing that we do. So that's not a thing anymore. So this is what we're seeing is one of the reasons that you got to be real careful about any sort of LLM generated result is who knows where that, like, exactly what that's from and how you operate with it. Is image.lock isn't a thing. So now our vector 2 is our center. That is still true. So we're going to iterate over this. And this is going to be image. Saying image set pixel. I, J. Is equal to this. To new color. This is going to be our RGB. I'm going to use a code. I'm going to use a uint. Okay, 3 floats. All right. X to center dot Y 0, 0. Just so. All right, so we have set our grid here, and when we move, it's gonna be like that get pixel. Oh, grid is not an image. Grid is a texture, and then once we've set it, we're gonna say grid. Hey there, Amethestra. Image texture dot create from image. Okay. What can we do off of the texture? Not that. We can get the image and then we can mess with it that way. But we could just store it as an image in that case. Okay, we are going to store it as an image. Grid. Okay, we can get pixel, which will give us a color. We are currently looking for some integers now. We are setting up a movement pattern such that we could save this off. Once we've saved it off once, we can load it from file. It doesn't need to be 10,000 by 10,000, but... Two, and that will be pixel red, pixel green. Okay. We have now built that. We test it again, see if it explodes. This is, we are doing the static load up. It is taking a while because, again, it is a 10,000 by 10,000 a loop there. Walk down to here. Spawn. Okay, that is incorrect. We know where the center is. One. Spin, spin, spin. We are still off kilter here. They've all stopped moving. Apply the offset. You get the pixel rounded to the nearest integer. This should give us an idea here because Hey there. Hey, Teresia. So we're getting there. We're trying to. I'm trying to be clever as far as some movement logic. Okay, tell me about Pixel. And red, okay. That is a reasonable number to use. And entity position, target position. Well, thank you for the follow. I think. Or Twitch is just behind. Would not be the first time. Okay, so we get our pixel. This is the actual direction to the entity. Not normalized. Oh, but negative. Negative. We need to be able to account for negative numbers. Because the pixel's only going to contain positive ones. So it might not be terribly visible, and there is some floating point precision going on here. But we're getting the absolute value of the direction to move, so that's throwing it off entirely. Which is why the ones in the upper left are converging properly. The ones in the upper right from where they spawn will move in the wrong direction. We're making a Survivor-style game in Godot using C#. I want to be able to use pixels, but there's no actual necessity to do that. It'd just be convenient, because that allows us to write it to file easily. And potentially to visualize it. Did I make my model myself? No. My model was done by Animation Studios. Dende and Inkcheck, model and rigger, respectively. I believe Animation is Kuramashit now. Like mass hit. It's hard to pronounce properly. It was commissioned, yes. How do we record this properly? Checking. Don't want it to be a color then. I think we can still wrangle this. Okay. Problem is, unit vector would be ones. And the coloration. Why don't use an overlay? I mean, there is one. That is the overlay. I just have my screen here. You know, upper right is overlay. Do you mean something else? I would want to be able to store this to a file, and I want to be able to keep the values. Can we store it in a different format? On Twitch, I don't have any sort of panels listed. Sound effects and similar. I haven't wired those up since I stream simultaneously on 3 different platforms. Anything that I set up needs to be the same for everybody. So like for subscriptions and whatnot, something appears in the upper right corner that is identical for everyone. What if we use... It's kind of hackery, but we might be able to get away with it. What if we do... our... Yeah. I don't have like an introductory thing like transitions and the like, do you mean? Sorry, there is something in the works for more complex screen Chrome or stream Chrome, but it's going to be a bit. It's a whole thing that I am doing. Okay, if we make a new color and we set its R8 value, but it's integer. How would we do this? So a unit vector would give us anywhere from negative 255 to positive 255. But we need to offset it. So if we treat each value as 512, as far as the fraction of it, that work? So what I'm facing here is that the actual pixel can't be a negative value. So I need to figure out how to translate that. If I look at it as the maximum value, I like I said, there is already something in the works for some changes to the stream UI and the like. But it's going to be a bit before it would show itself. It's going to be a whole thing. So if every pixel is actually treated as 128, and we're going to be using, it's a fraction of 0.5. So we are going to take it as we can either use the 1 or the 255. Don't want to use 255. So if it's a fraction of 1. I mean, put another way, Teresia, I'm not in the market for any sort of model or stream overlay updates. It's fractions of 1, which means 1 is positive maximum. And we would have it. So it's fractions of 0.5 that we're looking at. Okay, if we add 0.5 to it, then we can subtract 0.5. So normalized, we're going to get that vector. Then we're going to add 0.5 to... 0.5 isn't enough. Because we need it to get positive. And no matter what, the vector will be 1 in length at most. So we can have -1 through +1. But we need it to result in a 0 to 1. Or a 0 to 255. 0 to 255 is a hassle because it's an odd number. And it would have to be an integer. So if we look at it as 0 to 1, if the first 0.5 is negative and the second 0.5 is positive, we would add 0.5. So it would be, we take the unit vector as a fraction of 0.5. Woof. There's a big song and dance to preserve it as a unit vector in a color grid in order to save it cleanly. I said, Teresia, I'm not in the market for any additional commission work for artwork or anything. Uh, I appreciate that you are actively getting out there and seeking commissions and the like. That is, I respect that. But I do ask that you respect the fact that I'm already working with somebody. So if the unit vectors are fractions of 1 already, then I would subtract 0.5. Can't work because I can get negatives. Not at this time, no. Like I said, it's going to be kind of a big deal, so. It's part of a whole thing. Just don't think we can do it that way. At least how to get the math to work. To get the math to work. So if -1 is 0 and +1 is 1, then 0 is 0.5. So there is a loss of information at play here. There's a translation to this, and I'm just not. It's just not mapping for me. Because we could add 1 to get us to 0 to 2. And we could times 2 minus 1. All right, let's think this is off, but +1 divided by 2. can do this more cleanly. Center is equal to center plus new vector 2, 1. Here, and then we're going to do pixel.r. Not really. X is equal to pixel dot r times 2 minus 1. Y is G. I don't think this is going to work. So this is a test bed for the whole collision and navigation system. Okay, that's functional. All right, we have a kickoff point. Let's just check a couple things here. And all right, though, folks, with that, I think we're going to wrap up. So let's summarize where we got. We have circle-based GPU-driven collision going on. We have the starting point for map navigation. So what we created there at the end was essentially a flow map, an unobstructed flow map that says, okay, this is the location of everything. Or I'm sorry, this is the direction to get to the center, and the center is offset to be whatever your target is. So just by using those offsets, just by plus or minus, we can say the center is this, and based on that, check the pixel, do some math, go here. That's not a big deal yet, but it's a bit of a shortcut. It's like I said, it's not a huge win, but it's part of the kind of logic that we're doing. The next stage will be to create the room, and using some other data that says this is what the floor of the room is shaped like. We're going to create a similar pattern that tells us this is where the walls are and this is how you avoid the walls. So that anytime something would move, we can look at that and say, okay, you were here. We are going to push back in the direction that you were in order to get back there. There's song and dance we can do for that in order to make it clean. But that pattern where we have a texture and we're saying, this is where you are, this is how you should move, will be the starting point for having enemies move within the room, having objects move within the room while avoiding walls and obstacles and potentially each other by kind of compositing those things together in various ways. So we'll see how that works out, but that will be for next time. We're going to try to hit the ground running on that and really look at where the wins are going to be, like where the best value for what we're doing is going to be. In the meantime, though, folks, I hope you had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all of those kind of things. Those buttons down there are generally positive, and I'd appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means, as well as other options available in the link tree in my bio and video descriptions. With that said, I hope the rest of your day is good, and I'll see you next time.